Radian measure is an alternative to degree measure for angles. It's like using meters or miles to measure distance, or Fahrenheit or Celsius to measure temperature. Remember that something in radian measure is the measure of an angle, and the radian measure of an angle theta is defined as the length of A, the arc that subtends the angle divided by the radius of the circle. So here is the radius. This is the arc that subtends the angle A, and this angle measurement in here is equal to 1 radian. For a complete revolution, for theta equals 360 degrees, the length of the arc is equal to 2 pi r. In order to convert between radians of degrees, we take the number of radians that we have and we multiply by 180 degrees over pi. And to go from degrees to radians, we take our number of degrees and we multiply by pi over 180. So let's apply that to some practice problems here. Often the term rad or radian is omitted in terminology. An angle with a degree symbol is measured in degrees. An angle measured without a symbol is said to be in radians. So the first thing we're going to do is determine an exact and approximate radian measure of the following. So this is in degrees. So to change from degrees to radians, we're going to multiply by pi over 180. Reducing, this is going to leave me with pi over 6, which is approximately 0.524 radians. I'm going to repeat the same thing with 45 degrees. I'm going to multiply by pi over 180. Reducing my fraction is going to leave me with pi over 4, which is approximately 0.785 radians. The next two examples, we're going to go in the other direction, so from radians to degrees. So we're going to take our radian value and multiply by 180 over pi, allowing me to do some reducing here. And I'm going to get that this is equivalent to 60 degrees. And then 5.86 radians, I'm going to apply the same strategy, except I'm not going to get an exact value here. I'm going to multiply by 180 and then divide by pi. And so I get 335.75 degrees. The next two examples are about angular velocity. So in this case, Tommy goes on a horse carousel at the fair, and the horse is 9 meters from the center of the carousel. If the carousel travels through an angle of 5 pi over 6, find the length of the arc. So this is another formula that you need to know, which is the arc length. And this is that the arc length, S, is equal to the radius times the angle that the arc passes through, and the angle has to be in radians. So if I draw out the situation that we have here, I've got a carousel, I've got the horse is 9 meters away from the center, and I know that it's going through an angle of 5 pi over 6. I can find the arc length by multiplying the radius by the angle that it passes through. So I get that my arc length is 15 pi over 2. And so that is another application of radians. The last one that we're going to do is we're going to look at angular velocity, and we're going to use something called dimensional analysis to go through. And dimensional analysis means using the units that you're given to get to the angles that you want. So we want to determine the angular velocity in degrees per second. So this hard drive of computer is rotating at 7,200 rotations per minute. That's what RPM means. And I know that there are 360 degrees per rotation. So that's going to allow me to cancel those rotations out. I also know that there is 1 minute in 60 seconds. Oops, 60 seconds. So that means that I can cancel out my minutes. Now what I'm left with on top is degrees, and what I left with on the bottom is seconds. So when I multiply that all out, I get 7,200 times 360 divided by 60. The units of this are going to be degrees per second, which is what I'm looking for, which is 43,200 degrees per second. If I'm going to find it in radians per second, I'm going to take my answer in degrees per second, and I'm going to multiply by pi over 180 to change the degree measurement into radians. And this is going to simplify to 240 pi radians per second. So those are some examples of radians and how they're used.